Hello, mentors. Welcome to meeting 7 on the taxi cab geometry. And let's take a look at drones and equal distance. So these are the last tasks in this meeting. And the last equal distance is like the pinnacle where you really build this circle. So let's first take a look at drones. Remember, you already did fire dispatch, fire truck dispatch, and the cats. So you now have a lot of intuition. And now this part drones, it's about actually comparing Euclidean distance just in a straight line with the fire truck or the taxi cab distance. So you have a fire and you have 4 different vehicles, drones and fire trucks, that want to get there at the same speed. Of course, the drones just fly in any direction, and these trucks A and B have to actually follow the rules. So who you would have to rank who gets first and who would get last. So you make a decision on which vehicle to dispatch first. So here's the solution. Let's take a look at A first. So truck A to the fire is 9. Let's convince ourselves why it's 9. So you have to follow the rules. So you cannot go straight line. So you would say, for example, you could do like a stair. 1, 2, 3, 4, 5, 6, 7, and here 8, 9. You could also just do 4 plus 5 a little faster, right? Or here 5 plus 4. So A is 9. Okay, so not too close. V is similar. It's going to be just 1 plus 5, so 6. Okay. So far we have these values. Let's take a look first at the drone D. So they could either use a ruler to conclude that this distance is 5, or they could actually, if they know Pythagoras theorem or recognize this nice triangle 3 to 4, right? Right triangle of legs 3 and 4, the hypotenuse is 5. So they'll conclude that. There are several ways they can conclude that, even if they don't know Pythagoras. What's important here is not the Pythagorean theorem, but more the fact that you can travel in a straight line. For C, it's a little maybe less obvious, but you actually have a triangle that's 45, 45, 90 and has leg 5, so 5, 5. So they could use 5, 5 and use Pythagoras, or even if they know this triangle, x, x, x root of 2, or use a ruler. So what happens here is nice. They can actually do Pythagoras with 5 squared plus 5 squared, and root of 50, it's almost root of 49, so it's a bit more than 7. And then that tells us that the best is D, right? Because the distance is 7. Oh, sorry, B. So here would be B. Then C, sorry, yeah. So we put C here. Sorry, let's, oh, sorry. I had a mix the numbers. So D, it's the drone, that's 5. Yeah, so we're good. 5 is the least of these values. So the drone wins. This drone here wins. It beats this fire truck. Yeah, even if you thought maybe the fire truck could be closer in a straight line, the fact that he has to go down maybe, yeah, loses some time. The second best will be B, this fire truck here. Third place, the drone C with 7. And the last one, it's clearly A because the distance is too far, right? It's 9, so 9 units. So you could think, students could think that A beats C, right? Because it's closer in a sense that is below. But the fact that A has to travel following the taxi cab rules makes it arrive actually later. Finally, let's quickly talk about equal distance. This you make it into a game. So you're looking for distance of 4 from the park. So people could take turns in the geoboard or drawing. So you could put here 4, here 4. I mean, these would be the obvious cases, maybe that students could take first, but some students would be really challenge themselves and say, how else can we do it? So 1, 2, 1, 2, maybe here. Or just like a stair, 1, 2, 1, 2, maybe here, and so on. And then they could recognize that these are the same distance because moving to the park, the first move of both would be here, same place, and then they would do exactly the same route. So they have the same distance. So they could start noticing that there's these lines that are forming, right? These mysterious lines that may be forming. And that would give us this nice picture of the circle. So this is how a circle looks in Euclidean geometry. It's a rhombus. You cannot really rotate it. And this is the center. So it has the 4 cardinal points, so to speak, north, south, east, west. And then it has these interpolations or these line segments of all these tracks here. This is a discrete, of course, circle. So let's call this a circle. It's weird, but that's what it is in the sense that it represents equidistance from a center. Okay, hope you enjoyed this part of the meeting and see you in the next video. Goodbye.